Hi, welcome to part 2 of 3 on the reactions of alkynes. The first reaction I'm going to go over today is hydrohalogenation. In the hydrohalogenation, you will have either HCl, HBr, or HI, so HX here for general. It will add to alkyne via a Markovnikov addition. Right, Markovnikov meaning the halogen will add to the more substituted position. So if I have the following alkyne here, we're reacting with HCl. The pi bond will attack the hydrogen, leaving the chlorine with the extra electrons from the bond, and the hydrogen adds to the less substituted position. So you've got your hydrogen here, and then now you have your carbocation at the more substituted position. The chlorine will then come in with its negative charge and attack at the positive site. To give your final product. Now, if you have the same reactant, but this time excess HCl, you will get all the way down to the alkane. And we'll number the carbons to make sure we have the correct number. So 5 carbons. 5 carbons. Right, always good to double check to make sure. I know my professor for organic chemistry in college would automatically give you 0 points if you gave an answer that did not have the correct number of carbons. So always important to make sure you're labeling those carbons. Now, if we want anti-Markovnikov addition, so addition to the less substituted position, we can do that using HBr, only HBr. It won't work with HCl or HI, and a peroxide. So if we have HBr with peroxide, we will get addition to the less substituted position. And both the E and the Z will be products. Again, number the carbons to make sure we did this correctly. 5 carbons there. 5 carbons. And 5 carbons. So those are the different mechanisms and reactions you will have with hydrohalogenation. The next mechanism we'll go over is the acid-catalyzed hydration of alkynes. So in this mechanism, we'll start with the following alkyne. Four carbons with this alkyne. We react with a strong acid. So in this case, we'll use sulfuric acid. So we can kind of put in a cartoon H+ there. And the triple bond comes and attacks the dissociated proton from the sulfuric acid. The hydrogen adds to the terminal position, leaving a positive charge at the other end. Still making sure we got our 4 carbons. The next step, water comes in. So this is not going to be a reaction that takes place in concentrated sulfuric acid. You would have it in aqueous sulfuric acid or dilute sulfuric acid. The oxygens, lone pairs, will come in and attack to give now deprotonation can happen here, so I'll just label that DP, but you'll just have one of the waters, given this is acidic conditions, will pick up one of those hydrogens to form H3O+. So that's how the deprotonation will occur, and we'll now be left with just an alcohol there rather than the water molecule. So the next step, this is not going to be our product. We're going to undergo tautomerization now. So we got H3O+ floating around in solution, given this is a strong acid solution. And one of the pi bonds here will come and take a hydrogen from the H3O+. And when that happens, you'll still have your OH here, but now that will be a positive charge, and we've got 3 hydrogens down here now on that carbon. I'll just write them in to make sure we see where that 3rd hydrogen went. It added to the position right there. So now, given we have the positive carbocation and the lone pair on the oxygen, that will come down and form a double bond there. And then our last step, water comes in to take away the hydrogen from that oxygen to give our final ketone product. Right, this would be the enol, but that is not going to be our final product. The ketone here is the final product of the acid-catalyzed hydration of an alkyne. The next reaction we'll review is going to be Hydroboration Oxidation. This is going to install the hydroxyl group at the less substituted position rather than the more substituted position. So for this mechanism, if I had an isopropyl group and a methyl group, the isopropyl side is the more substituted position. You've got extra carbons over on that side compared to only the methyl group. So the reactants for this, I have BH3 in tetrahydrofuran, or THF, and then hydrogen peroxide and NaOH and water. Draw the arrow a little bit longer since we have more reactants. The product here, like the last reaction, it is a ketone, not an enol, but notice here it added to the less substituted position. That right there is the less substituted position. That would be the more substituted position. And here it has added to the less substituted and not the more substituted position. So our next video will finish off the alkyne reactions, starting with the halogenation of alkynes, followed by ozonolysis, and then lastly, alkylation of terminal alkynes. See you then.